Hi students, in this video we are going to see some of the problems related to properties of a system. So here the given problem, here we are going to check the following properties for this problem, and I will you explain one by one. So the first condition is what? Static and dynamic. You know that what is the static system? If the output depends upon, that is the output depends upon only the present input values. Okay, if the output depends upon only the present input, then the system is said to be static, that is it is a memoryless system. Okay. So if it is dynamic, the condition to be dynamic is it depends upon present input as well as the past and future output value. So it is set future input value. So it is said to be dynamic. Now consider the first problem, that is y of n is equal to x of n into x of n minus 1. So for this is the output. For the present output, it depend upon the present. This is what your present input, right? So it depends upon the present input, and here it depends upon the past output values, right? I told you that n equal minus 1 is equal to 0, so n is equal to 1. It lies on the positive side, so it is the past input. Okay, so here it is the past input. So if in order to store the past input, it need a memory. Okay, so here the system is said to be a dynamic system. Okay, this is the procedure to check. So how you need to write it? The present output depends upon present input as well as the past input values. So it need a memory to store the past value. So the system is said to be dynamic. Like that you need to write it. So the next problem is y of t is equal to cos x of t. So in this case, the output at the present output depends upon, that is the output depends upon only x of t, that is the present input condition. Okay, so whatever the functionality may be the system is performing, here it depends upon only the input, present input, just it is performing the finding the cause of this signal. So here there is no need of memory. No memory is needed, so hence it is said to be a static system. Okay, so here how you need to write is the present output depends upon only the present input. It does not require any memory, so it is said to be a static system. Okay, then now we will see the third problem. Y of n is equal to log 10 x of n. Okay, here also, here this is the output. The output depends only on the present input. It is performing the logarithmic operation on the input, so there is no need of no memory is required, hence the system is said to be static. Okay, next one, y of t equal to t into x, that is t into x of t. Here also y of t depends upon only on the present input values. It does not depend upon past input value, just is performing the operation with this x of t. So here the no memory is required and the system is said to be static. Okay, the next, what is the next problem? The next one is y of t is equal to e into x of t. Okay, e into x of t. Here also it is performing the exponential operation, so it depends upon only the present input. Then this is present input, no memory is required, so the system is said to be static system. Right, while solving problems you need to write it as a statement. The present output depends upon present input only, so it does not require memory, so it is said to be a static system. Like that you need to represent. Now I hope you have understand the concept of static and dynamic system. So the next one is causal and non-causal condition. Now consider this one, y of n is equal to x of n into x of n minus 1. The condition for causality is it depends upon present and past input values. Okay, so it is said to be a causal system if it other than present and past, if it depends upon future it is said to, that is it depends upon future, it is said to be an non-causal system. Okay, so now see the y of n is equal to x of n into x of n minus 1. So this output depends upon, this is what your present input as well as the past input values. So the system is said to be a causal system. Okay, system is said to be a causal system. Here suppose instead of this x of n minus 1, if you are having x of n plus 1, okay, this represent the future values. So okay, in this case it is a non-causal system. Okay, so this is what the condition for non-causal system. Okay, so here consider y of t is equal to cos x of t. Here only depends upon the present input. So here it is the present, that is it depends upon present input, there is no past input, so it is said to be a causal system. Next one, see here also the present output depends upon the present input, there is no past input, so it is said to be a causal system. Okay, here also y of t is equal to t into x of t. So here it depends upon the present input, so it is said to be a causal system. So similarly here it depends upon the present input only, so it is said to be a causal system. If we are having x of n plus k in your representation, then the system is said to be a non-causal system. Okay, hope you have understand this causal and non-causal concepts. So the next one is linear and non-linear system. Here we are going to check this condition, weighted sum of output is equal to output due to weighted sum of input. So what is the meaning of it is, here I am having x1 of n, I am going to scale by a factor a, then I am having x2 of n, I am going to scale by a factor b, then I am going to add these two and I am going to give it to a system. It is performing some functionality f, so the output will be y1 of n. So here there is another case, here we are having x1 of n and I am scaling by a factor a, here I am having x2 of n, I am scaling by a factor b, here I am transforming the signal into the system, transmitting the signal into the system, it is performed any functionality, so then the final output obtained is y2 of n. So here in this case, in order to have linear system, y1 of n is equal to y2 of n. So this is what we are going to prove it now. Understand, I think, hope you have understand the difference. Okay, so this is said to be weighted sum of output is equal to output due to weighted sum of input. Weighted sum of input means the sum at the input itself, so at the input side itself, here we have performed weighted sum of input. So weighted sum of input and then we are giving to the system. Here see weighted sum of output, here we are giving separately the signal, then we are performing the output, weighted sum of output, so which is equal to y2 of n. Now we will see this for a so far discussed problems. Okay, so the first one is what is the first problem, that is y of n is equal to x of n into x of n minus 1. Okay, so now consider you are having a signal x1 alone. Okay, so here I need to prove this, right? So what I need to prove, so this is any functionality or transformation, you can use it, it is denoted by this. So this functionality either you can denote it by t or by f. In some note, in some book they have given t or f, so anything you can use it. Okay, so plus transfer function, that is the functionality of the input. Okay, so here what we are going to do is, first I am going to check this condition. Okay, so consider here I am giving x1 input alone, I am going to check the first condition. So I am giving x1 input alone, right? So what is the, how will I, when I give it x1 input alone, consider this system is performing, that is x of n into, that is x of n minus 1, that is it is multiplying x of n into x of n minus 1. So x of n minus 1 represent the that is the previous output, just you need to give two inputs, so it is performing the y of n. This is the concept of this. Now what I am going to do is, so the first thing is I am going to find out when the input is x of n, the output will be y1 of n, which is equal to x1 of n, that is a x1 of n into a x1 of n minus 1, right? A x1 of n into weighted, and we are giving it a into x1 of n into a into x1 of n minus 1, which is a square, that is which is equal to a square x1 of n into x1 of n minus 1. So this is the y1 output. Okay, in y1 output, next one is we are giving x2 of n to this input. Okay, so x2 of n, y2 of n, which is equal to a into x2 of n, a into x2 of n minus 1. So which is equal to a square x2 of n into x2 of n minus 1. Okay, so I have done the steps. I have done the steps alone. I have done the step. I have applied to a system. This is what a system, and finally what we need to add it, we need to add the two inputs. Okay, so how I am going to add it? So y1 of n plus y2 of n I am going to add, so which is nothing but a square x1 of n, x1 of n minus 1 plus a square x2 of n into x2 of n minus 1. Okay, so I have done this step. Now this is what your first output. Consider this is the output 1. Okay, so consider this is a output 1. Okay, the next case is what I need to perform this one. So I have done this, I have need to perform this one. So in this case what I need to do is I need to, now we have find out this first one. So here see, here in this problem either you can use a or you can use b. Okay, so in order to differentiate I am using b square, but both are same. It is something a constant. So here I am replacing by, for x2 I am replacing by b square. Okay, now I have find out this one, right? Now I need to find out this. So what is the meaning of it? Just I am having a x1 of n plus b x2 of n. Okay, so this is what the total input. Now I have obtained up this point. I am going to give to the system, that is the I am going to obtain some functionality. So here now see this equation, I am going to give the input to the system which is doing the functionality x1 into x minus 1. Okay, so now in this case what we need to do is, okay, so wherever you are having x, there you need to replace it. Now how we need to replace is the output we need to obtain. This is the output 2. So the output that is after applying x1 of n plus b x2 of n. Okay, so what is your actual function? Y of n is equal to x of n into x of n minus 1. So what I will get is, so for x I will have a into, so I am going to, wherever I am having x, I am going to replace this function. So now see, so what you will have, a into x1 of n plus b into x2 of n. Okay, here for x of n minus 1, this can be written as a into x1 of n minus 1 plus b into x2 of n minus 1. So wherever you are having x of n, you need to replace by this function. Now see how what you are getting the terms. You are getting a square x1 of n minus 1 plus ab x1 of n x2 of n minus 1 plus here I have multiply a square x1 of n here, then ab x1 of n. So first what I did, a x1 of n x2 of n minus 1, then ab here x2 of n x1 of n minus 1, then ab x1 of n and x2 of n minus 1 plus b square x1 of n x2 of n minus 1. Okay, so now this is what your output. Now this is the output 2. Now check both the output, whether output 1 and output are not equal, right? So we have to write that, that is output due to weighted sum. This is sum we are adding, that is we are output due to weighted sum of input is not equal to weighted sum of output. So weighted sum of output. So the system is a non-linear system. Okay, like that you have to do. We are going to solve it for the remaining problems. Now consider this problem, y of t is equal to cos x of t. So first we need to find weighted sum of output and output due to the weighted sum of input. So weighted sum of output, first y1 of t means, here first we are applying x1 of t. So when you apply x1 of t, what you will get? I will get cos x1 of t. Plus when I apply x2 of t, what I will get? I will get cos x2 of t. Now this is the weighted sum of output. Okay, now we are going to apply weighted sum of input. So weighted sum of input represent, so here I need to do scaling, right? So a cos x1 of t plus b cos x2 of t. Okay, so ax1 plus bx2 of n I need to give here as an input to this. So what I will get? I will obtain y3 of t. So this y3 of t is equal to, instead of x of t I need to, here it is t, right? Instead of x of t I am going to apply x of a x1 of t plus b x2 of t. Okay, now see, this is what the equation 1 and this is what equation 2, both are not equal, so it is a non-linear system. Okay, so the third one is y of n is equal to log 10 x of n, the next problem. Okay, so first we need to find out weighted sum of output. Okay, so weighted sum of output means I need to find y1 of n plus y2 of n. So y1 of n I need to give input as x1 of n. So log 10, that is we need to perform a x1 of n. Okay, so plus log 10 for in this case x2 is the input signal, a x2 of n. Okay, so next I need to perform output due to weighted sum of input. Okay, so here a into x1 of t plus b into x2 of t I need to give. So when I give to this, what I will get? I will get log 10 a x1 of, here it is n, right? n discrete time. So a x1 of n plus b x2 of n. Okay, which is nothing but, here you will get this, you can write this as log 10 a x1 of n into log 10 b x1 of n. Either you can write it in multiplication, right? Okay, so here see, this is what log 10 plus log 10 n. So how we can write it? We may not able to add it. Okay, so in this case, so this is what your output 1, this is what your output 2, that is this is y3 of n, that is y3 of n is not equal to y1 of n plus y2 of n. Okay, so this system is said to be a non-linear system. Next one is y of t is equal to t into x of t. So the first we need to find, what we need to find? We need to find, that is weighted sum of input. Okay, so weighted sum of input. So here y1 of t plus y2 of t you need to find it. So here when I give x1 of t, I will get a y1 of t. So t into x1 of t plus t into, that here you need to scale, right? T into b into x2 of t. So this is what the output. Okay, so then now I need to give y3 of t. So y3 of 3 is nothing but a x1 of t plus b x2 of t. Okay, so I am going to give to the system now. So okay, so t into a x1 of t plus b x2 of t. Okay, now you perform a into t x1 of t plus b into t x2 of t. Okay, now see, this is the first one and this is the second one. Okay, so both are same, right? A into t x1 of t plus b into x2 of t. So it is a linear system. Okay, so this is what your linear system. Next see the fifth one, y of t is equal to e into x of t. Okay, so here for first what we need to find it, so you need to find y1 of t plus y2 of t. Okay, so in this case when input is x1 of t, the output is y1 of t. Okay, so here e into x1 of t plus e into x2 of t. Now I need to find y3 of t, which is nothing but a into x1 of t plus b into x2 of t. So which is equal to e into a x1 of t plus b into x2 of t. So which is e into a x1 of t into e into b x2 of t. So here this is the output 1 and here it is 2. 1 is not equal to 2, so it is a non-linear system. So like that we are going to check the linearity condition. So the next one is last properties, time variant and invariant properties. So here what we need to do is we need to prove y of n minus k equal to x of n minus k. Okay, so first we need to find x of n minus k. So in the output C, in order to find x of n minus k, so obtain this as y1 of n. Okay, the output is y1 of n. So wherever you are having x of n, there you need to replace x of n minus k. So x of n minus k minus 1. Okay, so here this is what your output 1. Now find y of n minus k. Okay, here this is the output y2 of n. So what is the meaning? Wherever n you are having at the output, that you need to replace. Now see here x of a, where you are having n here, so x of n minus k, so into x of n minus k minus 1. So now see y1 is equal to y2 of n. So it is a time invariant system. It does not changes with the time, so it is said to be an invariant system. Okay, the second one is y of t equal to cos x of t. Okay, so now see here we need to prove the same, y of n minus k equal to x of n minus k. So here first I need to substitute x of n minus k, which is equal to y1 of n, sorry it is x of t, right? Okay, so now here t minus, so for x of t you need to write x of t minus t naught, which is equal to x of t minus t naught. Okay, so now here I am going to first to find x of t minus t naught, which is equal to y1 of n, which is equal to cos x of t minus t naught. So wherever I am having x of t, there I am replacing x of t minus t naught. The next one is y of t minus t naught, which is equal to y2 of n. So here wherever you are having t, there you need to replace. Here I am having only inside x of t minus x of t. So here this is 1 and this is 2. So 1 equal to 2. So it is a time invariant system. Okay. So the next problem is y of n is equal to log x2 of n. Here also first I need to find x of n minus k. So here x of n minus k represent log 10 x of n minus k. So this is what your y1 of n. Then y2 of n is equal to y of n minus k. Wherever in output you are having n, there I am going to replace n minus k. So okay, now in this case both are same, so it is a time invariant system. Okay, so the fourth problem is y of t is equal to t into x of t. Now you can easily understand the difference. Okay, first you need to find x of t minus t naught. So this is nothing but your y1 of t. So wherever you are having x of t, there you need to replace x of t minus t naught. You should not replace for t. So this is what input is shifting. So x of t minus t naught. Okay, next one is what y of t minus t naught. So this is nothing but your y2 of t. So in output wherever you are having t, there you need to replace t minus t naught. So in output I am having t here. Here I am having x of t minus t naught. So here now see here this is 1 and this is 2. So 1 is not equal to 2, so it is a time variant system. Okay, understood? So the next one is here, fifth problem is y of t equal to e into x of t. Okay, so here x of t minus t naught, first I am going to find it out. Next here, that is y1 of t, which is equal to e into x of t minus t naught. Then I am going to find y of t minus t naught, which is equal to y2 of t, so which is also equal to x of t minus t naught. So 1 and 2 are same, so it is said to be an time invariant system. Okay, so hope you have you have understand the how to find out this causality, static and dynamic system.